Hi, I just needed to add a few more terms to this outline that I made in one of my other videos. Right here you have the t-score of a one-sample t-test. This is the formula for the t-score, which is the test statistic. And I was saying that when the curve above the sample means is normal, the curve above the t-scores, which is the t-distribution, has the correct shape that it's supposed to, which is called the t-distribution curve. And then having this t-distribution curve gives you valid p-values. And the bottom of the t-score formula right here would be called the standard error of the mean. It's the basic type of standard error that we talked about a while ago. And it's actually an estimated standard error of the mean, just because it uses a standard deviation of a sample, which is the S right here. So the bottom of this t formula for a one-sample t-test is called the estimated standard error of the mean. And I'm going to talk about what the estimated standard error of the mean is showing. When you do a one-sample t-test, you're selecting one sample of people who come from a certain population. For example, you might select 100 college students from a population of 19 million college students in the US and record data from those 100 college students. And you would calculate the sample mean of those 100 students. And the means of all of the possible samples fall under a curve, and the set of the means of the possible samples that are inside of this curve are called the sampling distribution of the mean. This is the basic type of sampling distribution that we talked about when we first started talking about sampling distributions. The sampling distribution of the mean is just the set of the means of all of the possible samples that could be selected. And this is important in a one-sample t-test because in a one-sample t-test you're selecting one sample from a population, and your one sample will have a mean, and that mean of your sample is just one possible sample mean, because each possible sample that could be selected in your one sample t-test has its own mean inside of here. And what the estimated standard error of the mean at the bottom of the t-score formula does is it estimates the amount of spread inside the sampling distribution of the mean. It estimates the spread of the means of the possible samples that might be selected in the one sample t-test. And let's also look at the t-score formula of an independent samples t-test, where you're collecting one sample from one population and one sample from another population and recording data from both samples. And you're actually calculating the mean of sample 1 and the mean of sample 2. In this t-score formula for an independent samples t-test, the bottom of the t-score formula is still an estimated standard error. that it's not the estimated standard error of the mean, it's the estimated standard error of the difference between the two means. And I'll talk about what that means. It's the estimated, the bottom of this formula is the estimated standard error of the difference between means. The entire bottom piece under this entire square root on the bottom of the fraction is the estimated standard error of the difference between means. And what is the meaning of this estimated standard error of the difference between means? Over here, in an independent samples t-test, you're selecting two samples, and each sample has a mean. So the top of the formula up here is called the sample mean difference. It's just whatever number you get by subtracting the mean of your first sample by the mean of your second sample. And every possible combination of people that might be selected for your independent samples t-test, or any possible combination of people that could be selected in the study that you're doing where you're planning to use an independent samples t-test, will have its own sample mean difference. For example, one combination of people might give you a mean of 3 for sample 1 and a mean of 2 for sample 2, and your sample mean difference will be 1. Another combination of people might give you a mean of 4 for sample 1 and a mean of 2 for sample 2, and the sample mean difference in this data set would be 2. So all of the combinations of people that could be selected in the study using the independent samples t-test has a sample mean difference. Every combination of people that could be selected for the two samples has a sample mean difference. And those combinations of people that could be selected fall under a curve. And this curve is showing how many combinations are available to be selected at each sample mean difference on this number line. This number line is showing the difference score for the sample mean difference. So if you, at the center, you have 0, and you have, well, you actually have 0 in whenever the null hypothesis is true. I won't go into that much detail about that right now. All I want you to know is that, or all I want you to know in this video is that all of these combinations that are stacked above 0 are combinations that have a difference score of 0, meaning this mean of the first sample minus the mean of the second sample comes out to 0. And this sampling distribution for an independent samples t-test is called the sampling distribution of the difference between means. So when I created that graph in the other video, where I made those boxes that had a dotted line in the middle, and where each of those boxes were stacked above a sample mean difference, that graph was showing the sampling distribution of the difference between means that's used in an independent samples t-test. The diagram that I made where you just had one sample stacked above its average was called the sampling distribution of the mean. When I made those boxes and I said I put 10 inside or 17 and there was no dotted line in the middle of the box, that was the sampling distribution of the mean. And the estimated standard error of the difference between means, which is the bottom of this t-score, is what it does is it estimates the amount of spread in the sampling distribution of the difference between means. It estimates the amount of spread between all of the combinations that might be selected in the independent samples t-test. And when I say estimated standard error of the difference between means, and I'm pointing the arrow right here, I'm not pointing the arrow at just this N2 right here. I'm actually meaning to point the arrow at the entire bottom of the fraction. So in both t-tests, the bottom of the fraction is an estimated standard error. It just, this one up here has a slightly different name than this one down here. And this one is estimating the amount of spread in this curve for one sample t-test. And this standard error, this estimated standard error down here, is estimating the amount of spread in this curve of the sample mean differences. And where I say the t-distribution curve around the t-scores, what I'm meaning is the curve that goes around the t-scores of the possible combinations, or the possible combinations of people that could be selected. And both types of t-tests have this t-distribution curve that goes around the t-scores of the possible combinations. The only difference is in a one sample t-test, your one sample that you select has a mean inside of this curve, and also that one sample that you select has a t-score inside of this curve. In an independent samples t-test, the one combination that you select, the combination of people, is actually a combination of two samples, sample 1 and sample 2, and that combination, this two-sample combination, has a different score, has a sample mean difference inside that's shown on this number line down here, and it also has, that same combination has a t-score that's shown on this number line down here. That same two-sample combination has a t-score that's shown on this number line. And the t-score of this combination that's selected in the one-sample t-test is calculated with this t-formula. And the t-score of this combination down here that's selected for an independent samples t-test is calculated with this t-formula. The t-score of this combination of two samples is calculated with this t-formula. And what I really want to do with this video is just mention some of the names for some of these concepts that I didn't mention before. Well, I discussed the concepts, but I didn't mention these names.